Hello everyone, welcome back to another Offensive Security C2 series video. In the last video we explored what it means to use Metasploit for basic command and control communications. Today, however, while we are still going to continue to use Metasploit for C2, we're going to instead focus more on the features it provides us as offensive security professionals. These features will include things like maintaining our access, features to help us escalate our privileges, and even move laterally across the environment that we may be in. Since this series is focused more on C2 and the features that various C2 frameworks can provide us, I want to be sure to point out that this will not be a comprehensive Metasploit video. I'm certainly going to skip over many of the awesome features that some of the more experienced among you may love to use in favor of keeping this video more generic. If you're interested in a more detailed Metasploit guide, I highly recommend the free Metasploit Unleashed course from Offensive Security, as well as the Metasploit Minute series by Mubix over on Hack5. If you're interested in more Metasploit content in the future and you'd like me to cover that content, please leave a comment below and I will certainly take that into consideration for a future series. With that, let's throw up the usual disclaimer and head into the video. So in the last video, I accidentally skipped over something important that I wanted to show in terms of C2 network communications within Metasploit. Fortunately, we have to establish C2 over on our target again for this video, so we can show the network communications in this video instead. So I'm going to get started by setting up our multi-handler to listen for basic reverse shell connections back to our C2 server. So we're going to use exploit multi-handler, just like we always do. And I'm going to set the payload to be a simple Windows, and we'll make it a 64-bit because we already know our target is 64-bit. Windows 64 shell, wait for it to tab complete. Shell reverse TCP, so simple TCP payload. I'm going to set my L host to ETH0 interface because that is the interface that I'll be listening on for C2 on my local network. And then I'm going to set the L port just to be the typical quad 4s that is usually by default, so I probably didn't even need to set that. But we're going to exploit that in the background, or aka run it as a background job. And then now we need to generate a payload. So I've already got a shell, as we see here. So I've already established basic command and control over this target. So I've got a simple 64-bit meterpreter shell that I've used to establish initial access. And what we're going to do now is upload a simple reverse shell that will generate. And we'll explore what those network communications look like when it connects back to us. So now I'm going to use the payloads module within Metasploit. And I'm going to use payload Windows x64 shell reverse TCP to match our multi-handler. And we'll kind of set the same options again. So we'll set lhost to be our ETH0 interface, which it automatically populated, as you can see there. And set lport to be quad 4s just to make sure. And then we'll say generate -f to specify the format as exe. And then we'll say -o and we'll call it basic shell.exe just to distinguish it a little bit better. So now I'll interact with my session that I have open. I believe it's session with an ID 2. Yep. And I want to just make sure I am somewhere that is easily readable. So I'm in the Windows root directory. And this shell, just for context, sorry, not get system, get UID, is a full system shell. So we're able to do everything we want to do. We've already exploited the host and escalated privileges. That's not going to stop us from showing off some cool privilege escalation features a little bit later on this video, though. So we'll upload our shell. What was it? Basic shell.exe. Awesome. And then now we can execute this using the execute module or execute command. And -h just makes it a hidden process. And I believe I also need to specify the -f flag as well. So we'll just run this with no arguments to see what's going on. Yes, so -h and then -f specifies the executable. So our executable is basic shell.exe. I created the process, and we should be getting a callback here shortly. Okay, there we go. It didn't want to show up even though we were in the background. So command shell session 3 has opened. So I'm going to interact with that, make sure everything's working okay. Looks like we're good, so we'll background this again. Now, what I want to show here is going to be some network communications with Wireshark. So I'm actually going to start up a Wireshark session here. Make sure it's listening on our ETH0 interface where our C2 is listening. And we're just going to run that in the background for a moment. All right, we'll interact with our session again. And now I'm going to begin just running simple commands. So I'll run a dir, a who am I, and we'll just cd :/, even though that's where we already are, and we'll run the dir again, just to kind of fill up with some data here for our packet capture. So now I'm going to go look at our packet capture. I'll actually stop it, give us some room here, and I'm going to go find some communication. So we know that it was TCP over 4444. And we are connecting to, this is our target at 2.104, back to our C2 server at 2.187. So we'll follow this TCP stream and actually see what that traffic looks like. Huh, that's a little bit weird. Maybe that's not exactly what we wanted. Let's go look for a better stream of data here. Looks like we followed the wrong stream, perhaps. There we go. That's what I was looking for. So what I want to demonstrate here is much like when you do a simple netcat shell with no TLS encryption, a basic meterpreter shell is the same way. There's absolutely no encryption. It is just a plain text shell. So defenders on the network can actually very easily see exactly what clear text commands you're running and what time you ran them and all that kind of stuff in their packet capture. So that's not good for us. We need things to be encrypted. And that's where meterpreter comes in. So what I'll do now is background this session again. And I already have a meterpreter session open, so we'll just use that one for now. Actually, you know what? We're going to generate another payload and do that. And the reason is that we'll actually need this other payload to perform some activities a little bit later. So let's go ahead and get that shell. That'll set us up for success later. So we'll say use exploit multi-handler again. Set it up the exact same way we did before, but in this time instead we're going to set the payload to be a Windows 64-bit weird autocomplete meterpreter, and we'll say reverse TCP as well. And it actually doesn't matter if you use a reverse TCP or a reverse HTTPS or HTTP payload. All meterpreter payloads come with encryption. The extra layer of TLS does provide you some kind of evasion techniques you can do. That's a topic for another video. But any meterpreter payload is going to give you this encryption out of the box. So we're just going to stick with a simple reverse TCP payload for now. And I'm actually going to set the L port to 9001 because I like IppSec, and you got to be over 9,000. So this should be all we need for our multi-handler. It should already have our interface set, and we can just say exploit-j. Now we can use the payloads module again to generate our payload. So we'll say Windows 64-bit interpreter reverse TCP once again. And we'll set the L host, make sure it's the correct interface, set the L port to 9001. And then we'll generate this also as an executable, and we'll call this met.exe, short for meterpreter. And I actually need to specify the -o. Awesome. So now we'll go back to our meterpreter session that we already have and upload met.exe, just so it's there. And our listener's already going, so we can do the same thing we did before, execute a hidden process of met.exe. Process seems to be created. Background this. And in theory, we should get a session come in. If not, we can go try to run that again, see if we had an issue. There we go. Not sure why it's causing weird issues having me run it twice, but it looks like we got our meterpreter session. If we do a get UID, looks like we are system. So everything seems to be loaded and working. All right, so I'm going to background this real quick. And much like we just did before, I'm going to start up a new Wireshark packet capture. And run this in the background. Oh, looks like both of those commands ran, so we actually have 2 sessions open now. So let's say session tac I4, since we know that's a good one. And I'm going to run a couple commands. So we'll run the get UID command. We'll run ls, which is dir. Meterpreter just kind of translates the commands for you with its standard API. We'll run the cd command again just to come right back where we were. Oops, they didn't like that too much. That's all right though. And ls again. All right, now let's go look at the packet capture this time. We'll stop it. And we can see we have a lot of data flow going. This looks like router communication, so we don't really care about that. So let's get rid of this. Here we go. So here's all this communication going between our target and our C2 server, and we'll follow this TCP stream. Look at that. It's all jumbled garbage, and that's because this communication stream is entirely encrypted, so it's just a whole lot of jumbled garbage mess. The defenders are going to have a hard time, actually seeing what's going on. There are signature-based detections and a couple other things to detect that it is a meterpreter-specific communication, but once your encryption is established, if you're actually able to get the connection out, like I said, evasion's a whole other topic for another video, but if you're able to get this out, you're pretty much good. There is no way they can actually tell what kind of communications that are going on. They can only see that they are encrypted and all scrambled up. So the more you can make this look like web traffic at that point, the better. It'll be more obscure. But I digress. That is the part in the last video that I left out that I wanted to make sure I showed, and we've done that. So make sure if you need encryption that you are using meterpreter payloads, the default shell payloads that MSF Venom provides, even if you're connecting back to a netcat listener or even the multi-handler. In both cases, it is all clear text communication. So just keep that in mind. All right, we're done with Wireshark. So now staying with the topic of meterpreter, let's talk about some of the basic features that meterpreter gives us with its standard API. One of the most useful set of features is the upload and download feature. You've already seen me use upload a few times now. So using the upload command, it just lets us easily and securely, for that matter, upload files to our targets. You can use this to put down more C2 implants for different frameworks just for persistence, or maybe get a special script uploaded for privilege escalation, whatever other enumeration scripts you may want to run, or maybe you just want to upload a fun picture of a tiny kitten, and you can make your target feel all warm and fuzzy. So I'm not going to show off uploading because we've been uploading our payloads this entire time. It's very straightforward. You just say upload and the path to the file on your local system. And you can also, I believe, specify in the second argument a path where you want to upload it to on your target system. But if you don't specify anything and just specify the file on your local system, it'll upload whatever your current directory context is inside the meterpreter session. So just like we saw here, I was in // and it just uploaded the file straight to // since that's where I was already at on my target. Now, next up is downloading, and this is where some more fun ideas continue to roll in. Much like uploading, meterpreter makes it very simple to exfiltrate data from a target system. So you may need that big juicy password.txt that's sitting on your target's desktop. Maybe you can't read it, but you can download it. And maybe you want a KeyPass database that you found to crack offline later. There's lots of neat use cases for needing to download files off a victim's machine, and this command lets you do that with relative ease. And so we're actually going to do that. I believe I know where a KeyPass database is on the system. So we'll cd into users and Biggie. So let's see. I believe it was in documents. Yep, database.kdbx. So that is a KeyPass database. And we'll use download right now to download that database. Awesome. So now that is sitting on our local system. So if I do a background and ls, we have it right here on our local system sitting in the same directory where we generated our payloads. Awesome. So that's really cool. Let me hop back into our session real quick. So we've been over upload and we've been over download. The next feature of Metasploit that I want to review is the edit feature. Now, this isn't anything fancy. It's actually just exactly what it says on the tin, so to speak. But how it works is sort of neat. So edit lets you edit a file on your target system using whatever text editor that you'd like to on your local system. The default is like it's either VI or Vim, but you can configure this to whatever you want by referencing the editor environment variable in your own bash profile. And the way the edit works, actually, is by combining both the upload and download features, essentially. That's kind of like the basic level. It could be a little bit more in-depth than that. It's been a long time since I looked at the actual edit module code, but that's more or less what it's doing. So edit downloads the file you want to edit, and then uploads your new copy when you're done. And this is really helpful as it makes the flow of adding simple changes to a file really easy without having to run upload and download over and over again manually. So let's take a look at that real quick. Let's find a file that we can edit. We'll just do the desktop.ini. It probably won't have much in there for us, but it'll be a good example. So we'll say edit. And now here we have a simple ini file that we've loaded into Vim in my case. And yeah, we can just edit this. So we can say hello. And we can write the file. And it looks like the access deny failed. Maybe even though we're system, we don't quite have permission. But that's how the edit command works. It's really simple. It just opens the file in an editor, and then if the write had worked, we would have uploaded the file. I didn't pick a good demo file for this video, but you get the idea. It's really straightforward. We can go real quick back to the root directory and see if there is a better file for us to try to edit. So we can say edit, maybe page file. That's this. I'll just write a 1 to it. Okay, so that one we did have permission to, but that's the page file, so maybe that was a bad choice. But I digress. We've been over upload, download, and edit, and they are all very basic and very useful commands that come standard with the Meterpreter API. So I like to use these a lot. They are very basic. This may seem very like, okay, man, let's get to the good stuff. So don't worry, that's what we're doing next. But I wanted to make sure we covered the basics first. So, like I said, these are all functions within the standard API Meterpreter, and there are a ton of functions. And we're going to explore a few more as we go through the video, but to close out this particular section, I want to show off Migrate. Now, Migrate is a command that is in and of itself basically black magic. And it essentially allows your Meterpreter session to attach and embed itself inside of another running process. This is crazy powerful for things like evasion, stability of your shell, lateral movement, and even process upgrades. I don't just like calling things black magic and then accepting them as a whole truth, though, so let me do my best to break down what's going on when we run the migrate command. So first off, we get the PID that the user wants to migrate into. This is going to be our target process. So let me actually kind of clean things up real quick and kind of show you the initial steps as we talk through them. So migrate, this is the help for it. We pass it a PID, and we can give it a name instead if we don't want to give it an exact PID, and a timeout. So we can do a PS to list the open processes, and we can pick any of these PIDs and pass this to the migrate command. So, like I said, step 1 is to get the PID that the user wants to migrate to, and that's going to be our target process to migrate. Pretty straightforward. Step 2 is it's going to check the architecture of the target process and determine whether it is 32-bit or 64-bit. And this is going to be important for memory alignment. And one of the really cool things we'll check out here shortly is that if I am a 32-bit process and I want to be a 64-bit process, I can actually just migrate into one, and it'll work. It's awesome. The migrate command will check what the process should be and align the shellcode correctly to update it to a 64-bit process. It's insane. The third check is going to check if Meterpreter has the SE debug privilege, and this is going to be used to get a handle on the target process. It's very important that you have the privilege to do this so that you can get the handle on the target process, or else this may not work super well. Since we're running a system right now, it's not going to really be an issue. Step number 4 is it'll get the actual payload from the handler, and that is what's going to be injected to the target, and it's going to calculate its length. Step number 5 is it's going to call the Open Process API to gain access to the virtual memory of the target process. And this is going to help it determine what it needs to allocate, which is actually step 6, which it calls the Virtual EX API call. And this is going to allocate a read, write, and execute memory block in the target process. Then it's going to call the write process memory API to actually write our payload, and actually take our payload and stuff it into the target memory that it's allocated. And then step number 8 is to call the remote thread API to execute that newly created memory stub that we made. So basically, we're creating a memory block, allocating it, shoving our payload in there after we've made that memory block executable, and then instead of executing it just as a process, we're starting a thread because we don't want to interrupt what's going on in the current process. So it starts the thread from that process, from the memory location that we've allocated. Then it's going to shut down the previous thread that has the initial Meterpreter from the process that we're migrating from, so that way we don't have two processes open calling back from the same, or calling back to the same instance. It basically gives us a seamless transition. So instead of it opening a new command session, we're able to just stay in the context that we were already in, which is really, really cool. So this is super complex, and sometimes it doesn't always work. But I think it's really important to go over how this works, because you can actually implement Migrate on your own using these standard APIs. So if you needed to migrate processes and you don't have Meterpreter, it's very important to know how it works, and that's why I wanted to go over that. Now, one of the most useful cases of Migrate is actually utilizing the PrePin migrate function whenever you're generating a payload with MSF Venom. This feature tells your payload that before it ever executes any actual shellcode or stagers, migrate to another process first. A common example of a use case for this is in exploits that have a greater potential to crash a target service. For example, if you are exploiting a bug in Internet Explorer that causes the browser to hang, well, chances are that a user is going to close that browser, which will kill your shell. PrePin migrate allows us to just latch onto another process as soon as our exploit runs, which means we will keep our shell even if the user closes out the broken browser instance. This also comes in handy if maybe we don't want to stick out like a sore thumb after our initial shell execution. It's really easy to notice a shell that's just running as shell.exe. In fact, we should probably notice that right here in our processes. We have met.exe running twice here. And I imagine there's some of these cmd.exes are probably related to our basic shell processes. But yeah, so we're sticking out. Oh, sorry, no, here's the basic shell. Yeah, we're sticking out like a sore thumb. So maybe we don't want to do that because that's real obvious. So instead, we can migrate to one of these mini SVC hosts that are the service-based host executable processes and just kind of hide in there, and we'll be kind of silent from there. In fact, I will demonstrate that now. So I will migrate from my current process, which is, I don't know exactly which one I am, but I want to go to another SVC host. And we need to make sure we maintain our system privileges, so we're going to pick this one right here that has system privileges, which is at 1164. And we'll run migrate. And so we're going from our 2740 process, which one we're actually, oh, so I hit the right one. So this is who we are. And it's taking a little bit. Hopefully it doesn't fail. Awesome. Migration completed successfully. Now if we do a PS again, you'll notice that our met process is gone. We still have the other one that's got the other shell open, but the one we had before is completely gone, and we're just chilling right here. This is where we live now, and we look completely inconspicuous. Now, another useful case that we will show a bit later is that sometimes we need to own a specific process to read data from it. Although system privileges are the end-all be-all on a Windows system, a random system level process can't necessarily see the keystrokes for File Explorer, for example. So SVC host can't necessarily see what is being input into File Explorer. As a result, it can be desirable to migrate to a process in order to perform like a targeted keylogging attack with a meterpreter session. So if I needed keystrokes from File Explorer, I can't get them in SVC host, so maybe I want to migrate over to the File Explorer so I can run the key scanner. Lastly, my favorite use case that I always forget I can do, and immediately feel stupid that I did forget, is that you can actually use Migrate to hop from a 32-bit process to a 64-bit process. Now, I already mentioned this when I was going over the steps, but this is just absolutely insane to me, and I want to iterate it again. Meterpreter can take its 32-bit shellcode and migrate it to become 64-bit, and this is super useful if you're unsure of your target's architecture or accidentally drop a 32-bit payload as part of your exploit. Some modules, as we will see, require that your C2 implant matches the architecture of your target, and if it doesn't, they won't work. And you can use Migrate in these instances to become a 64-bit process and regain full control of all the modules you'd like to use. Now, this does work the other way, of course, but it obviously does not work on 32-bit systems, as those systems wouldn't even be able to execute 64-bit code in the first place. So now I'm going to kind of demonstrate what I'm talking about with that, because that's kind of the most mind-blowing feature to me that I want to make sure is demonstrated. So we're going to use the payload module again, and we're going to generate a Windows meterpreter reverse TCP shell. And we're going to set the L port to 9002, generate F exe o 32bit.exe. Oh, got to set our valid L host. So this has generated a 32-bit meterpreter payload. Now we're going to use the multi-handler again to set us up a proper handler for this. First TCP, and we're going to set the L port to 9002, and exploit this multi-handler again. All right, cool. So we have our handler running as a background job, and we have generated our payload successfully. So now I'm going to use our session again and upload the 32-bit .exe. Awesome. So we're going to execute can't find the specified file. We're probably sitting in a different directory now that we've migrated to the SVC host process. So that's something important to keep in mind. We've completely changed context with our migrate. All right. It's weird that that didn't work correctly, though, even because that file should have been uploaded. Maybe it was just a full path kind of issue. So we'll upload that again, and then we'll attempt to execute it again. That's why it didn't work the first time. There we go. Run that in the background, and we should expect a session to come in very shortly. All right, so we actually did get our session in, and if we run a sysinfo, we can see right here that it is a 32-bit session. And what I wanted to demonstrate is that if I want to load, say, Kiwi, which will load in the Mimikatz module, for example, we won't be able to really use that. So if I try to run creds all, it just kind of works out. Even though we are system level privileges, it doesn't have an issue that we're not system. The issue and why it just doesn't work is because we're a 32-bit process. And I'm going to demonstrate that now. So what we'll do is migrate to one of these other SVC host processes, say 800. And it's a 64-bit process. Looks like we had a bit of an issue there, so let's try another process. So we'll say 1364. Awesome. Migration completed successfully. So now if we do a sysinfo, we are now a 64-bit process. And what that did is it should have migrated all of our modules and stuff that we loaded into. Since we already loaded in Kiwi, we can say creds all. And there we go. It works just fine. And looks like we got some nice juicy creds for this target. Awesome. So now that we've talked about migrate and some of the standard API pieces, I want to talk about post-exploitation persistence. There are a ton of persistence modules in Metasploit, but to keep things simple, we're going to talk about service-based persistence and registry key-based persistences. Starting with the basic exploit Windows local persistence module. So this is going to be a very simple module that we'll check out now. So we'll say use exploit Windows local persistence. So this is just out of the box a persistence module that exists. And the way this module works is it will install a persistence payload of your choice, define a registry key that will execute that payload on startup. And this way, if we ever lose our shell, we can just keep listening, and eventually when the system is rebooted, we should be able to pick up right where we left off. So I'm going to set a session here. We'll set session, let me see what sessions we have open. Set session 6, our most recent one. And so we can also set our startup type. We don't want to lose our system privileges, and we have system privileges now, so we'll set startup to system. And then here we can kind of just leave the defaults, but pay attention to them. So these are our arguments. So the exe name, it's going to give a random value by default, and it's going to write to the temp directory that's in the environment variable for whatever context we're running in. And it's also going to create a random registry key name and a random VBS persistent script name. So if you want to be more stealthy, maybe you want to name these to be explicit things that seem like they're supposed to be on the system, which may do you more good. But just for the proof of concept, we're going to run this as is. So we'll run the persistence module. And it looks like everything worked. Now, I'm not going to go through the process of rebooting everything because that'll just take too long for the context of this video. But you can see that it actually successfully executed all the steps. It wrote our VBS script for persistence. This is the registry key it created. And it installed the auto run for that key right here. And gave us a cleanup file to clean up this persistence. And this is really important, pen testers out there, or aspiring pen testers. You need to clean your stuff up after you get off the system. Whether you do it as a post-engagement activity or whether you're doing it as you go, you don't want to leave your client systems more vulnerable than they were. Typically, once a meterpreter session dies, it dies. So if you have an established persistence, that's one thing. But in this case, we've changed registry keys on the target system. This needs to be documented and removed. And so it's nice that they give you a helper file for cleanup. All right, so now the next module that we want to do for persistence, we're going to kind of sink our teeth in here, is the persistent service. So what this does, it'll set up a Windows service that is running automatically as soon as the system boots up. And as long as this service is configured to run, we should always get a shell back. So let's go take a look at that. The module for that is the exploit Windows local persistence _ service. So we'll look at our options. All right, so this has some similar options as the other module. So we'll set session to 6 again, and pay attention to the arguments once again. So the remote exe name and path, these are set to temp and a random string as default, similar to the other module. This is a retry time to retry anytime it's fails a shell connection. By default, this is 5 seconds. So you maybe want to set this for a longer period of time if you want to seem a little bit more stealthy. Say that you think they've cleaned everything off and you've been caught, but you still have this running and you know you do. Then you can just kind of wait it out and see if maybe it'll connect back over a period of time. That's just one particular strategy to throw out there. And of course, service description, service name, just more meta fields that can make your service seem more inconspicuous, so it doesn't catch your persistence mechanisms. So we're going to run this again. All right, and in this case, it actually starts us a TCP handler. So I'm sure there's some more advanced options we could actually configure here. And so it's making the meterpreter service. Here's what the exe is called. Create the service name. Gave us another cleanup file, which is super helpful, and it's actually sending the stage now and opened a meterpreter session for us. So now our service is set up, and if the service is ever rebooted or the system restarts, it'll try to connect over and over and over again, and it'll have a delay of 5 seconds, and once it's able to see RC2, it'll actually give us another session again. So that's really cool that it demonstrated actually giving us a session and that we were able to see that. So lastly, I want to go over the post Windows manage persistence _ exe. Now this creates an exe payload that lives in a temp directory and sets up an auto run registry key to execute the payload whenever auto run is triggered. Now this is very similar to the original persistence model, but it comes with a different setup method. So we're already here in the module, and we're going to take a look at what the options are. So I've came in and pre-configured a few things during testing. The first one is the remote exe name, and so this field is actually what the exe is going to be labeled as on the target system. By default, it is default.exe, and here's where things are a little bit different. Here's where you specify whatever exe you want. In this case, I'm specifying the meterpreter exe payload that we generated before, but this can be anything. So that's what's really neat about this persistence module is it makes it really easy for you to just toss any executable in the box and turn it into a persistent executable via the auto run keys. So we have our session 6 defined, and the permission we want to run it as system, similar to the other payload, and we'll hit run. I had a little crash there for a second, so I've renamed it to something different. I think it's having some issues with process handling, so now we'll hit run, and there we go. Perfect. So this has taken our met.exe, written it to a temp directory in thing.exe, executes the script that it needs, installs the agent with the proper PID, and then sets up those registry keys I mentioned for auto run. And then also, of course, gives us a cleanup file, which is super helpful. Now, there are many more persistence modules and persistence methods that you can use, but these are some of the most common, quick, and effective ready-to-use methods that are available as modules for the use of post-exploitation persistence in the Metasploit framework. Now, the next thing I want to talk about is actually privilege escalation. Now, privilege escalation comes in all shapes and sizes, but since this video is focusing on specific features of Metasploit, I'll just talk about one in particular. This is the local exploit suggester. This is a handy little post-exploitation module that will search for potential exploits that the system may be vulnerable to, specifically for privilege escalation, and it's super helpful for enumerating additional findings on the system in a pen test, but it's obviously clearly a helpful tool to find a path to privilege escalation, assuming you don't have the privileges already. So we're actually going to purposefully downgrade our privileges now. So we'll migrate to this IIS service on 2408. Awesome, migration was successful, and just to show that we are not system anymore, and we can't just do a fancy get system. There's no path or permissions where this service has system permissions. We are now running as the IIS app pool default pool. However, what we can do is use the local exploit suggester, and I don't actually know what the full path is, so we can say local exploit suggester in our search. That wasn't as helpful as I'd hoped it would be, so let's try search suggester. There we go. And so we'll use 0 in this case and show the options. So the options for this are pretty straightforward. Set session to 6, that's the one we want to do our recon on, and run it. And this will actually take just a second. It's enumerating all of the possible exploits that it can find inside of Metasploit as it relates to the version of the operating system you're running on. So this is actually cross-platform and will run on Linux or Unix systems as well. But it's going to suggest a few exploits for us here, and we'll pick one of them and see if it'll work. All right, looks like we have a lot of juicy exploits that this is potentially vulnerable to. One I like to use a lot is Juicy Potato, which is this MS16075 reflection juicy. So we're going to take a look at it because I'm pretty sure it's going to work. So we'll look at our options. And the session we want to escalate our privileges for is session 6. Now again, this is a C2 series. I'm not going to go over these exploits and how they work. So if you want to learn more about Juicy Potato, I may post some helpful links in the description below, but we're not going to configure anything fancy. We're just going to be script kiddies in this video and exploit it as it is. But yeah, if you want to learn more about this particular exploit, this is not the video for that. There are plenty of other videos. I think IppSec uses this quite a few times and does a great job explaining it. So look elsewhere for that, but we're going to use it anyway because we want our system session back. All right, looks like it was successful. We even had an early stage sent, so now we're just waiting for the multi-stage payload to kind of finish its handoffs. All right, meterpreter session 8 opened, and if we're lucky, that session is a root session. Woo, NT authority system, awesome. So now we've gained our privileges back, but I think we may have a problem here. Yep, we are a 64-bit payload again, so let's go back and use what we've learned today to migrate to a 64-bit process. So we can come to, I like sticking to the SVC host, so we can say migrate to 592. All right, looks like we're good to go. Now that we're system again, let's talk about one of the spookier things that I love to use Metasploit for, and that's credential gathering and lateral movement. First, we will take a look at one of the most simple things we can do once we're on a system, and that is hash dump. Hash dump also kind of does what it says on the tin. Inside your meterpreter session, you can dump all of the hashes that are tied to a given system. This is super useful for two big reasons. One, of course, you can take these and use them offline for cracking if you wish. Two, with most environments, a Windows hash is almost as good as a password. Even if you can't get clear text credentials, you can often use the hashes you collect to perform a pass the hash authentication with something like psexec, which is also built into Metasploit. So we're going to use that, which is actually, by default in our interpreter session. I think it's either with the standard API or the extended API. I can't remember, but assuming we did a multi-stage payload here, I would think it's safe to assume it's the standard API, but if you know, correct me in the comments below. So let's run hash dump, and there's all the hashes for the users on the system. The biggest two would be the admin and the Biggie hash, because these seem to be the two main users of the system. So we could actually take this and now authenticate via pass the hash attacks, or take this offline and try to crack it. And considering the password for Biggie we've already seen is kind of weak, maybe it'd be in a dictionary somewhere. I wouldn't be surprised. Hashes are great, but clear text passwords are almost always better, and that's where our good pal Mimikatz comes into play. Now, Mimikatz isn't quite as effective on modern versions of Windows without setting a few registry keys first, but that said, this technique is still extremely effective with enough patience, even in that case. However, for Windows 8 systems and below, Mimikatz is always super effective by default. Mimikatz does a lot of stuff that is well outside the scope of the series, but the built-in Mimikatz and Kiwi modules in Meterpreter allow us to easily invoke basic credential harvesting techniques inside our session using the power of Mimikatz. Basically, Mimikatz will let us invade the LSASS process and yank clear text credentials from memory. So we'll do that now and see what we find. And obviously, we ran this a little bit earlier in the video, but this is going to be more focused on Mimikatz specifically. So I want to make sure the Kiwi module is loaded in. There's actually Kiwi and Mimikatz. And Mimikatz is the older version of extension that they keep around to help out if you're targeting older systems like Windows XP. And I believe it would still work. So if we say load Mimikatz, yeah, so load Mimikatz into a newer OS. Did you mean to load Kiwi instead? So Mimikatz, I believe, would still work. And we can actually show help. And we can see what the commands are for each of these. So if we do a, for example, the wdigest command for Mimikatz, looks like it still works just fine and gives us our credentials. But typically you want to use the Kiwi module instead. And the Kiwi module is actually a lot more effective in some ways. So if you just know you don't want to go through each of these, you can do the creds all command, and you can also use this to generate golden tickets, which is also another topic for another video. But it's super useful, and that's why I wanted to point these out specifically, even though we've kind of already ran Mimikatz earlier in the video. But we'll run that creds all again from the Kiwi module, and it runs all of the most important things that we care about, giving us both the hashes that we'd want, any clear text credentials. Looks like even for Biggie $, we have randomly generated clear text credential. I'm not really sure that that's too useful for us, but either way, we've got Biggie's password here. So there we go. That's Mimikatz, and that's extremely useful. But the thing is, that's just the password to the system. And while users typically do reuse their passwords a lot, and this is going to be a big win for us in this case, there's one more thing I want to look at. Now, this is the last thing for this section, and I alluded to it earlier in this video, and that is keylogging. Now, even if all the other techniques fail, say Mimikatz doesn't work out for us and hash dump is bugging out for some reason, usually someone has to type in a password at some point. Meterpreter's built-in keylogger allows us to focus on a process and scrape the user's input from it. One of the coolest use cases I've heard of comes from Mubix's Metasploit Minute series, and we're actually going to show that now. Basically, our user is going to have a KeyPass database open, and that will have all their passwords, and we want access to that. In fact, we downloaded that KeyPass database earlier so we could hopefully crack it offline, but we haven't had any success. What we can do is notice the user has the processes open and is using it, and then we can migrate to it. We could even choose to kill it. Say we're thinking that they've already logged in, so we could kill it, wait for them to start it up again, migrate to it, and then start logging the keys. Now, I know the process isn't open yet, so I'm going to pay attention to my processes, and as soon as I see it pop open, I'm going to migrate to it. There we go. Looks like there is a KeyPass process. Now, keep in mind, we are a system shell, so we're going to lose our system privileges, but we have multiple shells already. We've established good persistence, so we're not too worried about that. We can sacrifice one session for the sake of hopefully getting all the passwords. So we're going to migrate there. This will take a second, and so timing is key here, and there are some automated actions you can do. Maybe you can set up a watcher to see when a process opens or whatever have you, but for the sake of the demo, this is just a proof of concept. Obviously, this is not efficient if you're doing the wild, especially since I'm talking over this, and the user's probably logged in by now. So we're going to do a key scan start to start sniffing the keystrokes, and then we're going to have them log in. So they've now logged in on their KeyPass database, and I'll do a key scan dump. Oh, looks like we got their KeyPass password. So it's the best password ever, huh? Well, what we can do now is actually open the KeyPass database. So I'm going to use KeyPass XC here. Open existing database. I believe I had it in our C2 videos. There we go. And we're going to try that best password. Typed it wrong. Best password ever. Make sure I did it right. I knew I spelled it wrong. And log in. And there we go. We've totally got all of their credentials now. Now, I believe some of these are defaults. So, yeah, that's a default KeyPass generated thing. But here's their Biggie password. So we've stolen that again. That's one of the scarier and more effective use cases of the Metasploit framework and using it as a C2 tool with meterpreter-based implants. Now, Metasploit Meterpreter does so much more in terms of feature functionality for C2. The caveat is that this tool is so good and so popular that most basic security defense tools detect Meterpreter implants with ease. Now, there are new evasion modules supported by the framework, and there's tons of documented techniques out there that are still effective when it comes to AV evasion to this day. So pros are always able to keep using the power of Metasploit. Since this series isn't about AV evasion or Metasploit specifically, I will leave off on that note. Hopefully you have all seen the usefulness and power of using the Metasploit Framework for C2 communications. It is very much an industry standard tool in the IppSec world, and while I do very much recommend looking into and using other frameworks for C2, Metasploit is always one you should have in your back pocket, especially since its versatility allows handling of basic C2 operations without using meterpreter payloads. It's always far more useful than a simple netcat listener when it comes to C2. In the next video, we will actually be looking into using what we have learned about C2 and C2 communications to build our own rudimentary C2 tool. Now don't get too excited, it won't be anything that isn't already industry standard and publicly known. But my goal is to help those looking to expand their techniques in this field by giving them the skills and knowledge on how to create tools of this nature on their own. After that, we will resume the series exploring other popular C2 frameworks just like we did for Metasploit. I hope you enjoyed this video. Please give it a like and consider subscribing to the channel. Stay hungry, keep learning, and thank you all for watching.